In this video, we will discuss the point group of water molecule and ammonia molecules. First one, point group of water H2O. Okay, this water molecule having structure like this. This is the structure of water molecule. We know that this water molecule, uh, which is a V-type shape, having V-type shape, we can pass axis through the oxygen atom. Okay, means axis of rotation, having axis of rotation C. When we pass this axis through oxygen atom, which divide this molecule into two equal parts. Okay, and if we rotate either clockwise or anti-clockwise, then we will get similar structure. Okay, suppose this is a HA and this HB. If we rotate, then here you rotate through 180 degree. Okay, then HB will attain the position of HA and HA here. Okay, means having C2 axis of rotation. C2 axis of rotation. This is the principal axis of water molecule. Principal axis of the water molecule. This water molecule having the symmetry element. One is the identity, another one is the C2 axis. This water molecule also having two vertical plane of symmetry. Why the vertical plane of symmetry? Suppose this is a water molecule, that type of water molecule. Okay, here consider oxygen atom, hydrogen and hydrogen. If we pass the plane through this molecule, and this is a axis passing through the oxygen, okay, that is the axis of rotation. If we pass the plane through this hydrogen, oxygen and this hydrogen, okay, that type of plane means having a plane of symmetry, and this plane which is parallel to the principal axis. Okay, this is the principal axis, and this plane which is also parallel to the principal axis means having vertical plane of symmetry. Having vertical plane of symmetry sigma p. Here, this water molecule also having another vertical plane of symmetry, because if we pass the plane through this oxygen, okay, suppose this is a water molecule, hydrogen, oxygen and hydrogen, then if we pass the plane parallel to the axis of rotation, okay, this is the axis of rotation, cn axis or c2 axis, and this plane, which this plane divide the water molecule into two equal parts. This part is hydrogen and this part is also hydrogen atom at equal distance, means having plane of symmetry. But this plane is also parallel to the, this plane is also parallel, a type of plane, okay, parallel to the C2 axis, and therefore considered as vertical plane. Means this plane, that type of plane is vertical plane, is having 2 sigma v vertical plane of symmetry. Okay, this water molecule having one symmetry element, that is the identity, another symmetry element, that is principal axis C2, another two vertical planes, two vertical plane of symmetry, and therefore the point group of the water molecule is C2V. C2V is the point group of the water molecule. It is the C2V point group. Okay, then we will discuss the point group of another molecule, that is the ammonia. Next molecule, point group of ammonia is NH3, point group of ammonia molecule. Okay, the structure of ammonia having one lone pair of electrons. Okay, that is the pyramidal structure. Somewhat pyramidal structure means here this consider this central atom nitrogen having three hydrogen atom. Okay, that is NH bond, NH bond, and NH bond, and this total here this distance or angle, it is 120. This is also 120, and this angle which is also 120 degree, means 120 120. We can rotate this molecule if we pass the axis. Suppose this is the axis, okay, axis, then we can rotate this molecule through 120 degree, then again 120, and again 120 degree. We will get symmetrical structure, means having one principal axis. Okay, this axis which is a C3, because we can rotate this molecule through this axis by 120 degree, 120 degree, and 120 degree, and they therefore considered as having C3 axis. Then this water molecule, okay, this water molecule having identity and two C3 symmetry elements, then this is the C3. Okay, major axis of rotation is C3 axis. Then this water molecule, sorry, ammonia molecule also having vertical plane of symmetry. Because suppose this ammonia molecule, okay, NH bond, NH bond, NH bond. If we pass the plane through this NH bond, suppose if we pass the plane through nitrogen and hydrogen bond, okay, that type of plane, then the remaining part, that is here hydrogen, here also hydrogen at equal distance, means uh, having plane of symmetry, having plane of symmetry. If we pass the plane uh, in this direction through this NH bond, okay, suppose here this nitrogen and hydrogen, then we will get to equal part, means having plane of symmetry. See here the plane, this plane which is a parallel to the principal axis of symmetry, that is C3, this C3 axis, okay, this vertical axis C3 axis, and this plane, okay, this plane, that type of plane, means this plane and C3 axis are parallel to each other, and therefore this plane of symmetry considered as vertical plane. Suppose this that type of plane, this plane is considered as a vertical plane. In the same way, we can pass the plane through this NH bond or through this NH bond. If we pass the plane, suppose this is the plane, then here this NH and NH bonds are at equal distance, means these are the mirror image. Okay, we will get to equal part. Is considered as this in ammonia having three vertical plane of symmetry. Okay, vertical plane of symmetry. Why vertical plane? Because these three plane are parallel to the principal axis, that is the C3 axis, is having 3 sigma V. Okay, ammonia having a symmetry element identity C3 and sigma V. Therefore, the point group of ammonia molecule is C3V. C3V is the point group of the ammonia molecule. Okay, C3V.